this video, we'll use Microsoft Excel to see just how many horsepower it's going to require to get the Bugatti Veyron up to its top speed. Alright, so let's begin. I'm going to start in column A, row 1, and I'm going to title my project Bugatti Veyron Polynomial Project. Alright, and in these next few rows in column A, I want to define some of the constants we're going to need. We need rho. Rho is the density of air. We need A, which is going to be the cross-sectional area of the vehicle. N is our normal force, and we said the normal force was equal to the weight when we are on a flat road. We need the coefficient of drag and the coefficient of rolling resistance. Alright, so I'm going to put these values in column B. Alright, so rho is 0.074225, and the units of that I'm going to put in column C. Alright, the units are pounds mass per foot raised to the third power. Alright, so pounds mass per foot cubed. Okay, I'm going to move down to the third row in the B column, and my frontal area of this car is 22.3, and the units of that will be feet raised to the second, so feet squared. Alright, the normal force, which will be equal to our weight is 4,189, and the weight is measured in pounds of force, so lbf. Alright, we said there was a difference between pounds mass and pounds force. Alright, so our weight is a force. Then we need the drag coefficient. Alright, and the drag coefficient we said for this car could be 0.36 in its race mode, but I'm also going to put over to the right here in row D, or I should say row 5, column D. This is adjustable to 0.41. Alright, so let's just make a note of that. The rolling resistance for this car with its special tires is 0.015. Alright, so I think those are all the constants we need. The next thing we need is to see, well, just how fast this car is going to go. Alright, so what's the velocity? Alright, and the velocity, we're used to measuring that in miles per hour. Okay, but for the equations that we're going to use, we also need it in feet per second. All right, so I just put miles per hour in row A, or I should say row 9, column A, and feet per second, column A, row 10. All right, so let's start at 0 miles per hour, and let me show you how to create a formula. Okay, so now make sure you are in column C, row 9. Column C, row 9, I'm going to hit the equal sign. Alright, so the equal sign comes up here. And I'm going to click on the 0 miles per hour, so B9, and I want to add 10 miles per hour to that. Alright, so now it tells me my cell, C9, the value is 10. But if I go back to it, you can see where this says FX up top, where the cursor is. Alright, it's really not 10 that's written in there. What's written in there is that it's equal to B9 plus 10. Okay, so B9 plus 10. And here's the great thing about Excel. Alright, so now that this C9 cell is selected, I can move my cursor over until it turns to the thin black cursor. Alright, so I'm going to move it off so you can see this again. I'm going to move it back on to the bottom right, and it turned into a thin black cursor. I can now click down with my mouse and scroll to the right. Alright, so I'm going to do that a couple of cells, and I'm going to unclick. And you can see how each cell is now the previous one plus 10. Alright, so we're filling in all of the cells. So let's click this again and move it all the way to the right. Alright, let's maybe go to AF. Alright, and if you go to AF, it'll fill in all the way to 300. Alright, so let's move the page. I'm going to hit my left arrow and go all the way back. Alright, So now we have miles per hour from 0 to 300. But like I said, we need the speed or velocity in feet per second. So now our conversion is, all right, for every 1 mile per hour, we're going to go 1.4667 feet per second. Okay, so again, in column B, row 10, I'm now going to hit my equal sign, and I'm going to say this is equal to my speed or velocity in miles per hour times 1.4667, and I'm going to hit the enter button. All right, so 0 times anything is 0, but as you can see, if I fill this 1 to the right, again by clicking in the bottom right, all right, 10 times 1.4667 is going to be 14.667. And now I don't have to keep doing this all over again. All I have to do is scroll all the way to the right until I get to AF again, right under my 300 miles per hour. So 300 miles per hour is just over 440 feet per second. All right, so let me scroll back to the left. Okay, so that's my velocity. Now let's talk about the forces against velocity, or I should say the forces against the force of the wheels moving us forward. All right, so drag. Drag, we have the rolling resistance. All right, and the rolling resistance and the air resistance, all right, these are forces, so they are going to be measured in pounds force. Okay, I'm going to actually come up here, all right, to my columns, and you see how this has a line now with an arrow to the left and an arrow to the right. I'm just going to move that over to the right a little bit, okay, so it doesn't cut into my wording down here anymore. All right, so we said our rolling resistance, this was going to be equal, all right, so again I hit my equals button. This is going to be equal to my coefficient of rolling resistance times, all right, my normal force, all right, and you can see again that's in pound feet, or I should say pounds of force, just like the rolling resistance is going to be measured in. All right, but here's what I want to do. All right, if I put this in just like this and I were to scroll all the way to the right, it would change the values, but the rolling resistance force is not going to change. So here's how we keep things constant in Excel. All right, I put my cursor to the left of B6 and I want to use the dollar sign. So the dollar sign is going to keep now the B column constant, but I also want to put a dollar sign after the B and before the 6 to make the row 6 constant as well. So now when I scroll, it's not going to change the B6 value. All right, I'm going to do the same thing for B4, all right, because our normal force is not going to change either. Okay, so now I have dollar sign B dollar sign 6 times dollar sign B dollar sign 4. All right, and I can hit enter. All right, now again, I want to click on this, and I want to drag it all the way to the right until I get to AF again. And you can see it remained constant. All right, so our dollar signs worked. So let me scroll back to the left. All right, scroll back to the left. And I want to talk about now my air drag. All right, my air resistance. And again, this is going to be measured in pound force. Okay, now we said in class this was going to be equal to 1/2, so I'll say 0.5 times rho times our frontal area times the drag coefficient. And now each one of these is going to remain constant, all right? So I want to put a dollar sign in front of the B and in front of the 2, and I'm going to continue that in front of the B and in front of the 3, in front of the B and in front of the 5. All right, now I'm going to put my cursor to the right of the 5 because we said it was 1/2 rho. We needed A and we needed CD, but we also have to multiply this. All right, so multiply it by our velocity. Now the velocity has to be in feet per second. So we want to click on B10. All right, now we don't put any dollar signs on B10 because that's going to change as we scroll to the right. All right, and it wasn't just times our velocity. We had to do the velocity squared, so I put caret 2. So that's going to square all of my row 10 values. All right, I hit enter. All right, and you see it's 0. All right, it's 0 because, all right, our velocity is 0. But as I move it, say, 1 to the right, you can see I'm increasing the air resistance. All right, so I'm going to click down and scroll all the way to the right. All right, until I get to 300. Now, I actually forgot to do something. All right, I forgot that this now is actually not in pounds feet yet. All right, we need to convert the pound mass, all right, from our row to pound feet. So I actually need to, all right, what I'm going to do is click on B14 again. I'm going to go up to my function bar here, the function bar where the cursor is. I'm going to click in it. And I actually want to divide all this by 32.2. All right, so I want to divide everything by 32.2, and that's going to convert the pound mass to pounds of force. And now I want to redrag everything to the right. So I got to click down again and redrag to the right. All right, and now I divided everything by 32.2, and I have my correct units. Okay, so that's my drag. So I get the drag from the air and the rolling resistance. So I want to make a new row, and I'm going to call this total drag. All right, total drag, and that's going to be, again, in force pounds. Okay. All right, again, I'm going to go up to my A and B columns here. I'm going to click down when my cursor turned to this vertical line with 2 arrows, and I'm just going to move that over so it's not getting in the way of my title here. All right, so total drag. What we're going to do here, now that I'm in cell B16, I'm going to hit my equal sign, and I want to sum both B13 plus B14. All right, we don't use any dollar signs because I want to scroll to the right and have these add the next columns as we go down. All right, so I hit enter, so that sum those two. I click on the cell, and then in the bottom right, I'm going to click down again and fill all the cells to the right to get my total force acting on the car that I have to overcome. All right. So the last thing we want to figure out is, well, how much horsepower do we need to overcome this? All right. Now we need to talk about two things. First thing is, how much horsepower do we need, all right, say at the wheel? All right. So we're not talking about horsepower at the engine. We're talking about horsepower at the wheel, and they're going to be different, and I'll tell you why in a second. All right. So we need horsepower at the wheel. So in order to solve for horsepower at the wheel, all right, I'm going to click in cell B18. I'm going to say this is going to be equal to, all right, it's going to be equal to our total drag, all right, and we're going to need to multiply that by our velocity in feet per second. And then in order to convert this to horsepower, we're going to have to divide by 550. All right, I could do that, and I hit enter. And you see it requires 0 horsepower to go 0 miles per hour or 0 feet per second. All right, which makes sense. All right, but now I want to fill in to the right. So what I have to do is put my cursor over to the bottom right of the cell, click down, and move it all the way to the right. And I go over here to 300, the miles per hour, and I unclick it. Okay? All right. So now we said the Bugatti Veyron needed 1,200 brake horsepower. Now, brake horsepower is horsepower actually measured at the engine. All right. What we just calculated here was horsepower at the wheel. Now, in a car, you're going to lose some horsepower from the engine to the rear wheels all right, because of internal friction of the drivetrain and things like that. All right, so what we're going to do now is say how much horsepower do we need, and this is going to be at the engine. All right, and it's tough to exactly calculate the difference between horsepower in the wheel and horsepower in the engine. All right, but we can say that there's going to be a 15% loss going from the engine to the wheel. So what I want to do, if there's a 15% loss, all right, what I want to do is I want to set my cell B19 equal to, all right, B18, the horsepower at the wheel, and I want to divide that by 0.85, all right, because that's going to account for the 15% loss. All right, so I do that, and I click on cell B19, click on the bottom right, scroll all the way to the right, all right, and that fills in the cells. All right, so let's actually take a moment and look at these two columns right here. All right, we actually said in class the top speed of the Bugatti Veyron was 267 miles per hour, and it had 1,200 horsepower. All right, so looking at these two cells, we can see, or I should say two columns, between 260 and 270 miles an hour, we need between 1,148 and 1,282 horsepower at the engine. All right, so this is coming right in line with what we expect to have seen. So let me show you one last neat thing about Excel now. So we know we want to be somewhere between 260 and 270 miles an hour. Let me scroll all the way back to the left, and instead of my B9 cell being 0, I want to start this at 260, and I'll hit enter. All right, now you could see that changed a lot of things in the spreadsheet. All right, my miles per hour is still counting by 10. Okay, but I actually want a more refined, all right, increment here. All right, so I'm going to change the value of C9 here, and instead of counting by tens, I'm going to say this is going to equal, all right, it's going to equal the 260, but now I'm only going to add to it 1. All right, so I'm going to add 1 mile an hour, and I'm going to hit enter. All right, so this changed everything in the C column, but now you can see D, E, F, so on, they're still counting by 10. So what I'm going to want to do is click on the 261, so that's C9, right click, or I should say click on the bottom right, and again I'm going to scroll that all the way to the right, and let me just scroll it to where I had the data before, A, F, all right, and I'm going to release it. All right, so now if I scroll back to the left, all right, this shows me 260, 261, 262, etc. All right, and you could see, all right, down horsepower at the engine, all right, we would have calculated, all right, that about 1,200 horsepower would have gotten us to 264 miles per hour. So that is a pretty good estimate of what the Bugatti Veyron actually did. We saw in the movie that it got to 267 miles an hour. So without doing any field testing, we can see how close we have gotten. All right, so what this shows is how powerful these calculations are before actually going out and doing this field testing. All right, because you saw in the video, there's a lot of people out there, you had to rent the track, and it costs a lot of money to do these things. So we simulate as much as we can in the computer before we go out in the field and do field testing. All right, so now we actually have a spreadsheet which we can play around with some of the values and see how it's going to affect our top speed. All right, so now you have this spreadsheet, and we could use it for future problems.